Hello, Michael or Dr. Alvaro. This is Noah DeMullen and Connor Simone, and we're showing you our code for assignment 2. Unfortunately, we didn't get everything done, but we think that we got some things done that you might like. As you can see, as I'm increasing the frame, it is 11:28 p.m., so we're in a bit of a hurry. The things are moving slow just because of weird...
The computer is not great enough to handle the frame rate.
Haha. Anyway, it's just a thing that Visual Studio does, but this does run perfectly fine. So as we can see in the scene, we have our elephants moving around, we have our one light moving around. We just didn't have time actually to even rotate it, but obviously we can just set world position, change around with coasts and stuff like that. But as you can see, when we're moving around our light, it is doing deferred rendering passes using this sphere. As it goes around, it applies normal geometry and diffuse models. As you can see, the scene would usually be gray if it weren't for the fact that these elephants are all actually colored in the code. So if we're going to go into things, this is what a full Fong model would look like. The second button just said have it without deferred rendering, and so I just decided I'd throw in the Fong model, and this is what it looks like with the standard lighting pass. Second, we have we have values of the geometry, and this is how we basically did our depth without doing a depth buffer. This is one of the three elements that we throw into our G buffer, and basically it's what's showing us what's in front of what and how the depth is working. These are different color values by red, green, and blue, basically being the X and Y, and then a combination of both X and Y values. Next we have normal mapping, which is basically a representation with the RGB values in tangent space perpendicularity, I believe. And those are basically showing what's the light's bouncing off of. We can do some cool stuff with normal mapping, but not in this one. Then we have our solid color. This is our diffuse color, and this will be just our standard color and how things will reflect off with the light. This, unfortunately, was going to be our accumulation, so button press 6. But unfortunately, that's not working right now. If we press 7, we have some objects that are also changing in mesh. We'll explain that a little bit later, but basically, we just ran out of time. And as you can see, we are able to change the meshes and change that to base what our light is. Alright, so quickly looking into the code. I know that I'm talking quite a bit, but Connor will also show that he knows what he's doing. Going into the code, we basically declare frame buffers. Our frame buffer object of... Ooh, where did it go? Frame buffer, frame buffer, frame buffer. Let's search it. Oh, we're actually quite down in the code. So yeah, right here we created frame buffer object, FBO. This is the main one we're going to be using, but we kind of go down. We are declaring different types of textures that we'll be using here. We're kind of going down, linking those, creating frame buffer or windows, which take up the screen width and the screen height. And then we go down all the way through this code. We just got some MGUI stuff going on here. Update scene, draw things, and we'll go back to that later. But basically what we're doing in each pass is we are binding and unbinding the data to be saved onto these textures that we then later use in our G buffer. So as you can see in this part here, we're getting our normal shader, we're getting our fragment shader. Or initially we were actually putting these into quads just to show proof of concept, but yeah, these are being saved as shaders, and then we're throwing them into the default shader, or we're getting the results of it from our default shader, and then throwing that in to our G buffer. Scrolling down, blah, 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 we have the bind things into our accumulation buffer for our G buffer, and these are being bound, and then we have one more, which is this 0, which is going to be the result of this texture. This is taking in the normals, the color, and the position, and then we have specular, just because our normals were misbehaving. This is a value that we also got from our default shader, but we just passed it in because, like I said, normal's going really specular. That's kind of why there was some brightness when we tried to merge it in part 6, which is the blend. Anyway, going down, we have our specular calculations. Basically here is a little bit interesting because we're using coordinates of GL chord to have the position of our scene onto the specific place that the scene is rendering from. This is actually, if you were to look, these are not actually lighting up these specific points in a way. These light calculations are all on their own. So if we were to actually get rid of this draw, which we actually did just for the purpose of having these in the scene, you would see that it's kind of more so texturing the specific components of where we have it. Going through this, we have the passes, and then we're using this new data, or the data that's being passed in from the default shader, into a standard Phong model, and that's how we're getting our result, finally, in frag color. And then we're just returning that, throwing it onto a sphere, which will be the result, and drawing the render camera scene, which is kind of like our wireframe shader in our standard light, and that's kind of how it goes. Yeah, like I said, we didn't have time to do some of the things that we wanted to do. For instance, with the default shader, we were trying to attenuate, default shader, we were trying to attenuate by timesing our normal by 5 and then plus 5, and then later on passing it in and correcting that in... Oh, sorry. And correcting that within our normals back here with ×2 minus 1. Anyway, I've talked long enough. Connor's going to explain a little bit of some of the things such as the circle and how those wireframes are working. Yeah, Connor, over to you.
So the way that we're getting the wireframing for the objects to work, it's actually quite simple. Just inside of the game object CPP, if we go and check it out, we can see that we have new variables. They're just little bools for wireframe and if it's light. And how we use this is inside of our main here. We're just basically going and just closing this just so we can find things easier. And then okay, so inside of here, this is our draw scene function, just iterates throughout the game objects. And as you can see here, it's checking if it's not a light, draw it regularly. If it is a light, then it checks if it's supposed to draw a wireframe. Draw wireframe is just a global bool that we declared up top in main, and then it changes the polygon mode to GL line. Then it draws the game object and switches the mode back to GL fill. That's pretty standard, and that's just so that when we're actually inside of the game here, you can see it's like drawing the sphere, for example, and we can toggle this through ImageUI here. It's just, yeah. What else was there?
How are you changing the cones and like the objects around if we hit 7?
Okay, so inside of our, where is it? Update scene function. It's just checking. This is another global variable, volume, and it's basically checking what the volume number is. We changed that inside of the keyboard callback function. I'll show that in just a moment. And basically, it just sets the mesh of the game object that we're using. This is just the name for the pointer's sake. It's just changing using the mesh of the sphere or using the mesh of the cone or the cube, etc. And just because I said I was going to show that off quickly, you can see inside of here, this is just switch statement, keyboard callback,